Lesson 814, Moving Day, Transformations on Grids. In this lesson, you'll use the terms that we've been using, translation, rotation, and reflection, to precisely describe transformations on a grid. And you'll also use a grid to perform translations, rotations, or reflections. Normally, if you're looking at these lesson recordings and you've been absent, I'll tell you to go to the Desmos activity and try it out. But I think it's a little awkward today because much of it was direct instruction. So let's just take some notes and talk about some of the things that we did in class. The learning goal is to use those terms, translation, rotation, and reflection, to precisely describe transformations. We'll talk about how precise you need to be. Helps if it's on a grid. Gives you some places to refer your descriptions to. And not only are we going to be describing transformations, but you're also going to be performing transformations based on directions. Use a grid to perform transformations. These skills are a little more difficult and are going to take some more practice before the next assessment. But we are working with grids today. Grids can help us to be more precise when describing those translations, rotations, and reflections. And something we need to introduce is this prime symbol. It looks like an apostrophe. So let's explain what the prime symbol means in terms of transformations. You see two figures here, and they're, kind of the same size and shape. It's just that it looks like one is a reflection of another. Looks like we flipped it over. And we have one that's A, B, C, D, and then one that has the same letters with the corresponding vertices, but it has that little apostrophe looking thing. So the prime symbol indicates that the point was transformed. It indicates that that's the image. So that prime symbol indicates that a point was transformed. And we'll find prime symbols on an image. If this is our pre-image, hope I'm using the same colors I've done with all the others. If this is our pre-image with A, B, C, and D, then the one with the primes is the image. So I can see that this point, if I reflect it to the other side of this line of reflection, the point gets a prime. This is going to be our image. The image has the primes, the pre-image does not. So we're going to label our images, we're going to label our images as we perform some transformations down here. And at the same time, we'll talk about what was important about that description, what you have to include in a description that's a translation, rotation, or reflection. Scooch down a bit. So we're going to draw the result of each transformation. We're given the pre-image, and we're asked to draw the image. And our first one is a translation. And we are asked to translate the triangle 4 units up and 2 units to the right. So it's going to be a translation. There are 2 things that you need to include when you're describing a translation. You need to tell what direction you're going, up, down, left, or right, and the distance that you're traveling. And that's what we have here. When it said 4 units up, 4 is the distance, and up is the direction. And there were really 2 translations here. We had one that was 4 units up and one that's 4 units up, and a second one that's 2 units to the right. But both of them have distance and direction. So if you need this transparent paper again to help you see what's going on, to see that every point moves the same amount, then you can grab some transparent paper and do that. But I'm going to take this point C and move it 4 units up. 1, 2, 3, 4. And then 2 units to the right. 1, 2. And that's where my new point is going to be. Since it was C that was transformed, I'm going to label this point C, but I'm going to give it one of those little prime symbols. This is C, this is C prime. And all the points move the same distance and direction. B is going to move 4 units up and 2 units to the right. I'm going to call that B prime. And A is going to move 4 units up and 2 units to the right. I'm going to call that A prime. Let me get my Tinkerbell here. And go ahead and draw that figure. So my new triangle, my image, is A prime, B prime, C prime. So in order to describe a translation, we need direction and distance. Our directions were up and to the right, and the distance was 4 and 2. Let's talk about how we describe rotations. In order to describe a rotation, I really need 3 pieces of information. I need to know that pivot point, the center of rotation. I need to know how many degrees I'm rotating, and I've got a trick for that if you have transparent paper. And I need to know what direction we're going, clockwise or counterclockwise. Just draw a little arrow so you know what I mean by direction. All right, so I've got my same figure here. And let's see if they have those 3 things. The center of rotation. Yep, they said center C. The degrees said 90 degrees. And the direction, they said clockwise. So we're going to rotate triangle ABC 90 degrees clockwise using center C. All of those things are important. So here's my figure. We're going to rotate it. Let's start with that 90 degrees. There's a trick to rotating it 90 degrees. Find that center of rotation that you're going to use. They said use center C here. And what I'm going to do is I'm going to look at the grid and make a little cross. And when I rotate, that's really going to help me to see when I've gone 90 degrees. I'll show you what I mean in just a moment. Okay, so 90 degrees clockwise, so I'm going to be going this direction using center C. All right, so watch this with the rotation. I'm going to put my pencil on that rotation, and I want you, as I'm rotating to the right, I want you to watch the little cross that I drew. And what I'm looking for is when that cross lines up again underneath that transparent paper. So since I drew that cross, I can tell, okay, now I'm at 90 degrees. I'm going to do that one more time. I know you could back up the recording, but I'm going to do it one more time anyway. So I have my center of rotation. I drew a cross using that grid line behind the transparent paper, behind that center of rotation, and it just makes it easier if I watch the cross to see when I've gone 90 degrees. Okay. And then you just have to be real careful as you're going underneath the transparent paper to mark where B prime and A prime are. Just gotta hold it. There's B, there's A. Okay. So transparent paper, rotations are kind of hard without transparent paper. So this is now both point C and C prime. A moved to here, that's A prime, and B moved to here, that's B prime. We need a center of rotation, degrees, and direction. And finally, let's look at reflections. We only need one thing for reflections. I have to know where the line of reflection is. Where is the line of reflection? You have to describe where it is. Okay, the recording cut me off a little bit and I went on without knowing that I got cut off. So we just finished up saying that we needed to know where the line of reflection was. Let me just talk through the rest of the notes that I took without you. Some important things to remember when you're performing those transformations on a grid. First of all, for a reflection, just count carefully. If you're told 4 units, count carefully. Secondly, for rotations, there's a trick to using that transparent paper. And the trick is to mark a little cross on the grid on that transparent paper where the center of rotation is. That'll help you to see when you've gone 90 degrees or 180 degrees. And finally, as you're making reflections using transparent paper, just mark the figure and fold along that line of reflection. You can line a ruler up there on transparent paper, fold along that line, and then it's just easier to flip it over that line once you have the fold nice and neat. So you might need to pause the video to jot these things down. Sorry about the hiccup in the recording. So all of these tools are to precisely describe transformations on a grid and also to use a grid to perform transformations. Good luck on the homework.